Okay, we're going to take a look at the basic sine graph for now and look at the transformations that occur around it. We need to talk about some basic features of the sine graph, and these also apply to a cosine graph as well. So the first thing that you'll notice as the key points, 0 and 0. It's not undefined, I don't know why I'm saying that. 90 and 1, 180 and 0. 270, -1, 360, and 0. These are our key points. That's undefined, but we don't need to worry about that. But that's 0, 0. So these are key points of a sine graph. Now, the features of a sine graph, amplitude, period, lines of symmetry, to notice lines of symmetry, and any vertical shifts that might happen. And so when we talk about look at a basic sine graph that's had nothing done to it, we can see that this there is a wave, and the height of this wave is basically your amplitude. Now, what you do is you need to have a line of symmetry. I'm just going to click this on, and I'm going to move it up so you can just see that that's the x-axis, and for this particular graph, the x-axis is my line of symmetry. You can see that the wave here is symmetrical about this line. And also what happens is by putting a line of symmetry in, what happens is this distance between the line of symmetry and the top of the wave, that's your amplitude. And in this case, it's 1. So the amplitude of a sine graph or even a cosine graph that hasn't been changed in any way is just 1. That's the normal amplitude, 1. Now there's also period, which is just how far the graph goes until it repeats itself. And if you start here, at this point here, you'll notice that it does a wave up and a wave down, and it completes itself at this point. So the period of, again, a sine, and the same again with the cosine graph, is the period is 360 degrees, if we're talking about degrees. So that's where it completes itself, one cycle. Okay? Now, there's no vertical shift. This hasn't been shifted up or down, and we know that because it's going through 0, 0, and so on. So those are the main features. Now, let's take a look at what happens. I'm just going to click that off and click this one on, and you can see it's just a basic sine graph, exactly same position as the other one. But let's look what happens when we move A. A is in front of the sine. That's its location. It's going to be some value. In this case right now, it's 1. Let's move it to 2. Now, if you take a look at the amplitude, that has changed. And instead of being an amplitude of 1, we now have our line of symmetry hasn't changed, but the amplitude has, it's gone to 2. So that number in front of sine or cosine or whatever it is, A, has to do with your amplitude. It tells you what your amplitude basically is. Okay, let's put that back down to 1. Let's take a look at B. Now B, if we take a look at B, B is changing how often, like the wave happens, a complete wave. It's stretching it so that a complete wave is going way past the page that we can actually see. If we go to 0.3, and then if we go to 1, it's a normal completion at 360. If B is 2, then this thing now completes itself. If you take a look, starting here, it now completes itself at 180. So instead of 360, if B is 2, the wave has been compressed, so now it completes itself in a shorter distance at 180. Guess what happens if I go to 3? It completes itself again here, which is 120. Imagine that, 360 divided by 3, 120. Okay, and so on. So the B affects the period. It changes the period. Okay? Now let's just put that back to 1, normal graph, and let's look at what C does. C does what it does to every other graph. It moves the graph up and down. It's a vertical slide. So if you take a look, now the thing about vertical slides that we know about is that when you change a vertical slide, you change other things like asymptotes or whatever, but also line of symmetry. The line of symmetry was there, but look now where the line of symmetry is. It's moved up. In fact, it's right where C is. So the line of symmetry basically is identified by C. So you can actually, if you know what C is, you know where your line of symmetry is, and that's kind of nice. Or vice versa, if you know where your line of symmetry is, you know where C is. And again, the amplitude from the line of symmetry, just 1. I can change the amplitude if I want. I can change it to 2. So again, if I know my graph has moved up 1, then again we've got that going on. And we've got an amplitude of 2 from that line of symmetry. 1, 2. Down, 1, 2. So amplitude is A. B is not the period per se, but it affects the period. And C is just your vertical slide, and it has to do with the line of symmetry. It tells you where your line of symmetry is, and it can be very useful to think about that in terms of where your amplitude is going to be. If you can find your line of symmetry, you know where your amplitude is, you know where C is. It's a very valuable thing to know. And that's the basic transformations of a sine graph. Now, we can do the same things for a cosine graph. Basically, the period and the amplitude of a basic sine graph are exactly the same. Just get rid of that. But look where it starts. No longer starts in the same position. It starts at 0, 1. So a cosine graph basically finishes itself at 360, but you can see the difference in the shape from a sine graph. So you have to know where you start from and where you're ending from. We'll do a little bit more work on this, but I just wanted to get this finished for now.